Okay, so I'm actually now going to join the panelists and sit down as well. And we can begin. And maybe we start far out, Seb. So I'm going to ask you, looking back at how you got into data science and where you are today, what initially were the key competences and what were the key turns that led you into data science?
Okay, so hello everyone. So as Chris said during the introduction, my background is in physics. I'm a PhD in astrophysics, and I've been through an entire career, actually, for 15 years up to the professor level. And also, I keep saying as well that I have been through a career change from academia into business, in the business world. My daily life never really changed. Basically, looking back, what drove me into science in general, not especially data science, was the need and the true passion to answer questions, complex questions. And what I learned throughout my career and during my training as well is the methodology to answer those questions, which is the scientific methodology. And I think that's basically what you need to start with data science, like in any science, is really try to understand how you can answer questions with what you have in hand in technology and apply a methodology, and then that leads us to replicability and statistics. So using statistics, because this is the best way to answer questions, not to put too much of your personal biases into it, so just use stats, and then technology leverages, so there's something that you learn on the way. So looking back, it's basically first this passion, secondly understanding the methodology, and then a good knack for the technology and trying to have an impact with what you have currently. You can always look forward, which type of data sets I need to have to answer questions, but it's always preferable to start answering the question what you have in hand and learn the technology on the way. So I think training is not something that you stop. You're constantly learning, basically.
Okay, thank you, Seb. Daniela?
Yeah, so my background is as my first degree is biochemistry, and then I started a PhD in neuroscience at some point. At that point, I didn't know any programming at all. My PhD was about genome networks during brain development, and that was 2007, and it was a time when there was lots of new technology about whole genome sequencing, but there was not a lot of technology and tools available to actually analyze the data. So I got into data science by this need to analyze the tons of data that I had, and at that point I just learned R and command line tools and analyzed the data myself. So how to get into data science and why I like it? So the first skill, or the first skill that you need to have is you have to be a bit fearless. You just have to go in and do it. It doesn't matter whether you will learn how to do it. It's fine. So this is one thing. The other thing, what I think is really important, is to have an understanding of what data actually means in the real world. Because if you just stick to statistics and abstract numbers, it's going to be difficult, in my opinion, to have or to come up with something meaningful. So these are two important skills. After I finished my PhD, I came to Berlin and I started a job as a referent to the CEO. And by that time, I wasn't very good at kind of selling my own work. But I had to learn how to do it. I was there 2 years, and I pretty much learned how to do good slides. And now I know how to do it. I also notice how important it is, because it's a nice life skill in the job, because it makes things a lot easier.
Okay, thank you. Clement, your turn.
Okay, so as Seb said, I'm also a physicist. Actually, not looking outwards astrophysics, but I'm a particle physicist. I went in 2007 to CERN, which is big data, sensor data. And I mean, for me, it really started also with a curiosity. I mean, the thing is that you have tons of data, and if you apply the right methods, you can really literally find out what holds the world together. So that was a starting point for me. And what I learned there was, well, you have to be creative and pragmatic to find something out. You have to ask the right questions, but you also have to be very rigorous in your use of statistics. You can easily make things up if you're not careful. And I think that is something that laid the foundation for me. I think also there, we more the practical parts. I mean, I think I learned enough programming to just handle data. I think that's a foundational skill still as a data scientist. And then for me, what was really the career changer, so I also, after my PhD, I went into business. So I came here to Berlin to work for a company builder. I was a sole data scientist in a marketing team. And I think that really accelerated my career because it totally forced me to focus on what is the value that I'm creating for the business. I mean, no one in the company was interested at all in statistics and in methods that I would apply, so I couldn't, shine with my deep knowledge. I just have to deliver something valuable.
Thank you. So some of the things that I heard is that in your previous life, you all encountered data in one form or another. But that there's also sort of a difference between encountering data in doing research or doing science and what you now do, because several of you mentioned that you need to be creative and pragmatic, and that you have to make do with what you've got, for example, or you have to focus on what the value is in terms of business rather than what it is in terms of new knowledge. So there's also a certain kind of turn. So following on from that, and maybe perhaps in the same order, so if you look at what you do today, where are you today, what are the 2-3 key skills or competences on the technical and business side that you think are really important to what you do?
Actually, I would like to comment on what you're saying, because I don't believe that when I was in astrophysics for 15 years, the impact that I had was actually the focus already there. And I don't see there's much difference. It's not because it's fundamental science that you don't want to have an impact. At the end, academics, through several of us in the room, you have to get grants, you need to get money. It's a business. This is the same way, and you need to have
Fair
this
enough.
focus.
Yes,
but yeah. So I think today there are a couple of things. First of all, we have this technology that is available. You have heard and overheard that throughout the days, and the level of accessibility is lowering with time. So we have all those really fantastic tools that are getting out that make it easier actually to deal with data today, even for people that may not have now the very deep background in computer science and statistics to do that. And I think for companies today, like basically Certace is a consulting / temporary placement company. So we're placing data scientists into companies, and we also advise the companies what they can do with data science. And the level of understanding in the business is somehow pretty poor of what we can do with them or for them. And what you need is first to be able to identify what problem you can solve with the data that is available. So it's a combination of pragmatisms. It's like there is data there. You can always advise your client or your CEO, we're going to acquire data for the next 10 years, but that's not going to solve the immediate problem of the business today. So I think this resourcefulness and the ability to identify the business needs or the physical needs or the chemistry needs for answering your problems and tackle it to the data that is there available today is the first thing you need to learn. And it requires a business background. And I think you see it in the panel. We have 4 PhDs on the couch there. We don't need to do a PhD to do data science for sure, but at least we all went through this methodology, and that's the important part, this ability. So I think the business is the focus on the business, on answering questions, is the first point that you need to really tackle. And secondly, be able to systematically use proper scientific methodology via statistics to answer those questions. So the rigorousness required is quite important here. And then when it comes to the technology, I think we start breaching in there. It's like there are people here in the room that are really able to develop to the next stage this technology. You will have a very strong focus. At the end, I heard over different discussion and panels over the yesterday that as part of this technology, for instance, in natural language processing, requires really to go deep and the level of specialization increase there. So you have the high-level technology or low-level technology that's available by the business to solve their common problems, but part of those questions are very, very complex to answer. And you will probably see more and more a separation between generalist data scientists that have a business face, and more specialized data scientists that are going to dig into the problems. So at the day of today, you probably want to choose that path, or you really want to have an impact on the business, and you need to acquire the high-level understanding of the business needs and the technology, or you want to bring this technology further, and then you will need to develop really the deep understanding of deep learning on the natural language processing, and you cannot do it all. So data scientists is a mixed bag of people with different competencies and not a homogeneous crowd at all. And I think this trend is settling today and is increasing. And from a business perspective, you may have a core need, so there's something that is really core to your business, in which case you need to acquire specialists, but in general, you won't need those specialists. So you will see more and more of these specialized skill sets coming in tech companies or as freelancers and independent professionals.
Thank you, Daniela.
Actually, I would like to pick up on something that you said, namely that data science in the business context is not so different from research. I think there's one important difference, at least in my experience, and that's the time frame that you're talking about. Because
I agree.
In business, you often have to deliver something quickly. And even if you're working on a large project, it tends to work better if you have several smaller products or rollouts before you come to an end. Part of this is transparency, because we always need to explain what we're doing, and there needs to be the sense that we are on track. I actually also appreciate this pressure to push something out in between, because there's also you can test what you've done in the meantime, so you don't go all the way to the end before you actually have a result, or you know whether what you did worked well or not in the real world. So this is one thing. The other thing I would like to pick up on is generalization versus specialization. I actually totally agree on that one. And I think for people who want to go into data science, it's important to find out where they want to be. So do you really want to be this technical expert who is very good at NLP, for example, or at image recognition or things like that? Or do you want to be more broad and where the strength would be, for example, integrating business technology and data and serving really at the intersection there. So this is something that's different for everyone, and it's important to find out where you stand and where you want to be.
Clemens?
Okay. Yeah, I would go a bit in the same direction again. I think the first key skill that you have to acquire is you have to be able to figure out in your situation what delivers value to the company. So that means, of course, figuring out the vocabulary of the business people, and that, of course, depends very much on your circumstances. And then it's a collaborative working effort. I mean, you have to make sure that you're not sitting in your little lab, dreaming up great ideas that in the end fail because no one wants them. I think everyone that's been in the business side has seen these kind of projects, which is not nice. From the technical perspective, I would add maybe that I think that the hardest part is actually getting into data science. But then it's such a wide field, and there's such enormous opportunities that it's, from my perspective, still very easy to make radical changes, to really work on very different projects. I think you're not, just because you're now the expert in image recognition doesn't mean you can't be doing speech recognition the next day, or totally turn things around and just do analytics.
Can I ask something about this? Do you think that's going to be the case in 5 to 10 years from now? I think so. I don't think we're moving that fast. I think we're really moving. I mean, I know also from the acquaintance I have, you have a very large split between the people that are very focused on particular subject matter. For example, doing machine learning for autonomous driving, or maintenance and Siemens. Those are people that are doing really hardcore one way only. They're a huge data science team, that 20, 30 people, so they're all very specialized.
And then you have on the other side, all the Berlin startup scene where it's kind of like free for all. You basically don't have much, maybe not even have much guidance on what you should work on. Yeah? If you bring good ideas that are valuable, you can drive them. So I think that those you will probably have still those two fields.
Okay, thank you very much. You've noticed that we've been talking about data, we've been talking about business, we've also been talking about the transition from science into business. And perhaps the next thing we should do is we should talk about code and coding, because you may look at us and think, do we actually know how to do this? And you're obviously aware that data science or machine learning comes with coding. I'd like to get us started by taking a look at Data Science Retreat, and first of all mentioning that if you were to look at us, you could see that among the participants, about a third actually do have a PhD, but that also means that 2/3 actually don't. So the majority don't, and this is absolutely possible then to become a data scientist or machine learner, just in case you were wondering. And then obviously, if you look at Data Science Retreat, the other thing is that there is things around coding and being able to do data science and machine learning through that. And then we have applicants, and we try to check who's a possible participant. And obviously, we actually do focus on what you've heard here today, so a general sense in terms of numeracy, statistics, possibly linear algebra, that they've done something with this, that they know how this works, that they have a clear motivation why they want to do data science, and that this includes a recognition that this will be within a business environment and what that brings with it, and that they have an idea where they want to go. And obviously, Data Science Retreat then is about learning to code or getting better at doing this. Daniela initially mentioned that you taught yourself R, the programming language R, right? So, Seb, when did you get into Python?
Actually, quite early, in 2000 something.
Okay.
As a good physicist, I started learning with Fortran, which is probably used only in academia. It's mainly self-learn. I'm not a I mean, when I was head of data science in the past 3 years in different companies, my team hated me when I was proposing to help them in coding because I'm probably not the best coder out there. It's more a patchwork of languages I've been using throughout my career. Python is very somehow easy because there are lots of it's a scripting language. It's the barrier level to enter into it is not too high, so you can start easily with it. There are tons, especially today, tons of libraries available. Same with R. The advantage of Python is also it can export easily in production. I never considered myself as a computer scientist or a coder. I can do it. I'm more pragmatic, means doing my career in astrophysics, and even later on, it's more how I can solve this problem with what I know and what I have, and just figuring out. I'm not a full stack coder. I'm a full stack overflow coder, actually. Just like spending a lot of time browsing the web to look for the solutions, and I think. That will make the huge difference with someone that really wants to specialize in one of those very specific trend in technology that will require this background and this rigorousness in coding, while my expertise is more lying onto understanding the data sets and how we can use it. And I think that's really a light, again, what I've been saying. You don't need to have a PhD, it's right. And actually, you see it when we look at the pool of talents we have at Certace. So Certace is a network of data scientists, freelancers that we're placing. You realize that a large fraction of them, or like 1/3, have a PhD, very similarly. But also it differs on the specialty. When you look at people that are more like, I would say us here, more on the trying to derive insights and understanding from data sets. People are coming from a higher level of education, PhD, scientific backgrounds, while you look more to the people that are actually coding and hard coding and machine learning experts or engineers are coming from a more computer science background, software engineering, typically do not need to go through a PhD as well. So we see that as well. And if you look into data engineering, the main part of the data engineers I know are actually bachelor or masters. So it depends on what you want to do. I think the difficulty and what is confusing the hell out of our business stakeholders is that data science is just not a homogeneous crowd, and we need to keep that in mind. We're trying to, but everyone has been trying to rebrand himself a data scientist. It's just very common buzzword today, and maybe we owe to our stakeholders as a community to make it a bit more clear where we specialize and what we can do exactly. So that's maybe food for thoughts.
Following on from what Seb said in terms of heterogeneity or homogeneousness, one thing you can do is you can go on LinkedIn and put in a search query, and then first put in the search query data science and see what results you get, and then put in the query data scientist and check what results you get. It's quite enlightening to actually see what happens there, just in terms of sheer numbers. And then you can go and check in you click people and you check in your network who's a data scientist. It'll give you a pretty good impression of what's going on there. But going back to the coding, so Daniela, you taught yourself R. I presume you also learned Python at some moment. Can you expand a bit on the relevance of the programming languages and what you might recommend looking into if you were to start again now?
So my first programming language was R, and this is actually still my main workhorse during the day-to-day work. I also like to use Python and PySpark, and then database languages or big data languages like Hive, things like that. When choosing a language, I think it depends really what you want to do. So as you said, job types are very heterogeneous. It's a range from what used to be analyst and is now called data scientist analytics to machine learning engineer. It really depends whether you want to start writing production code or not. Personally, I don't like that very much. I can't write production code, so I'm happy with R and Python. We have machine learning engineers. They mostly use Scala and Spark. Needs to be the right tool for the job. You need to find out what kind of job you want to do.
Clemens, your languages?
Well, I started out with C++ and very gladly moved away when I had the opportunity to use Python. And then I went to business. I was really lost. None of my physics programs for data analysis worked, so I started learning R on my own. And that's actually in my realm now really the workhorse. So now that I also have a team, it really helps to have everybody on the same page. So I'm really glad we are really heavily using R, and then Python and PySpark for the big data needs. I would add that, especially if you go more into the analytics direction of branch of data science, collecting data is still in many projects, I don't know, takes 50 to 80% of the work, and I think SQL it was actually the first thing I had to learn when I went to business.
Thank you, Clemens. I'm going to do a final round, a final question, while you, if you like, can start thinking of questions you might like to ask. We have about 12 minutes left, so a quick final round. So we've spoken about the data, the business, the coding. You all have interesting roles at the moment. If you look out and you were to think about advising somebody on starting out with data science, they're thinking, do I do data science and machine learning? Is there anything specific you would recommend what they should do or look out for that you think is important as the field is now moving forward?
I don't think focusing on language, the language you're using is irrelevant. I think the only one that will stick is probably SQL, because that's the one that you will have still to use to query. Ruby is there, Lua. It will change constantly. So pragmatically use what you're comfortable with or what your colleagues work with. Remember also that data science is a cross-functional job. It's a team job. I mean, within data scientists, but also when you develop a product, you're working with software engineers, you're working with data engineers, you're working with the business stakeholders, which is important. It's cross-functional. And data scientist on his own has a limited amount of things that he can do and a limited impact on the business. So building up in a company a team of data scientists, put them in a dungeon and tell them, well, when you have something useful, come back to us, will never have an impact on the business. You want to spread them across the company. me. So I think if you want to start to embrace this type of career, you have to first be driven by this passion I mentioned before, and learn. You keep learning. You never stop learning. I've kept saying to my students when I was teaching that actually I learn more by teaching that they did by me teaching them. I think you have to keep learning and reading and keep yourself on the top of the waves. So yeah, be driven by your passion about what you're doing.
Thank you, Seb. Daniela?
I think my main advice would be to, so one thing is to join a team instead of being the sole data scientist, because so if you're in a team, you're going to learn a bit more of the day-to-day data science skills, also technical skills. If you're on your own as a data scientist, what you will probably learn is more speaking the business language. Which is also important, but I guess in the beginning, more important are technical skills. What I would also recommend is getting some real-life business experience, because this is important. This is also what people look out for, because there's always, or there tends to be the doubt that people who come directly from academia are going to be a good fit. I personally don't think it's a big problem, but there is always some adjustment time, and you can shorten this time for your future employer if you already have some experience.
Thank you, Daniela. Clemens?
Well, I'll make it short. I think just jump in. I mean, just apply yourself. And if you have trouble getting traction, getting that job, then just do it yourself. I mean, just find a try project, something that is interesting, useful, and use that to demonstrate your drive and your skills.
Okay, thank you to the panel. And over to you. Questions, please. Please, can you stand up? Would you? Oh, there's a microphone coming too. Wonderful. Yeah, that's...
the sound, yeah, good. Thanks a lot for the discussion. I was waiting for this panel discussion, and I wish I was there because I have much comments on this. First of all, everyone talked about the methodology, the scientific methodology, Sebastien and Daniela. At one point, Daniela said that there is a difference between academic and business data science. I was like, no, and she said time frame. I said, okay, that's great, fine. The point is that, the discussion was wonderful. The main problem in a career in the data science education nowadays is not what is data science, but also what is not data science. And there are two main problems in this world. One of them is called Kaggle. The other one is Coursera. And they made both of them are very useful if you know how to use them. On the other side, both of them made this huge illusion for many people that we are data scientists. I mean, this is not my property, of course, and everyone is welcome. But the point is that what problem I have in my company is that many interviews are terrible. Terrible. We get applications with high salary, and she comes, and the first part of the question is what is supervised learning and unsupervised learning, and the answer I really got was supervised learning when the teacher is with a student, and the unsupervised is when a student does self-study, and that's true. That's really true. Thank you for talking about scientific methodology. At the end of the day, this is about science. This is about dynamically updating the knowledge, and unfortunately this import XGBoost .train .test is not whole the story. I would like that you shortly talk about what is not data science, these illusions which is in the community about, okay, there is a huge race of let's become a data scientist. We cannot deny that, fine. So who is not data scientist? That is also a question. Thank you.
Okay, thank you.
Well, I think it's difficult to... You should not... you shouldn't define yourself by what you're not. I think that's a dangerous exercise. But what I agree with you, that's that the difficulty of having this entry level to use these technologies, lowering, and that's why we keep insisting on methodology and scientific. It's science. It's a rigorous journey you're going on. It's just not tweaking and turning knobs that will make you understanding and have an impact on the technology. So, on the business side, they're completely right. I mean, it's not because you have been doing Kaggle and managed to be on the top of the board without understanding what you're doing that you're going to be able to apply that in real life. And I think that's more or less what came on as a common theme. What is interesting there as well is that with this level lowering is that people that do not have this scientific background or not have a PhD in science but are pure business people can start also looking into this, not become data scientists themselves, but start be able to use this technology themselves to have an impact on their business. And what we see, the trend and freelance jobs, independent professional jobs is getting more visible, Upworks, Certace, and all tons of companies out there that are exploiting that, is that we will see I truly believe that this level of specialization will be less and less required in some of the main part of the business, unless it's your core business. So when you hire a data scientist, the first question, you want to hire a data scientist, the first question you need to ask yourself is that, do I need a data scientist? And I think that's somehow what you're saying is that people claim to be data scientists because there is a buzzword, and companies believe that they need to have data scientists with understanding what they need, actually. So you got on the market a lot of people that believe they are data scientists because they can tweak nodes and get jobs, actually, right? And I think we need to clarify really what data scientists are. Does that basically join what you're saying, right? And for me, it's methodology.
Thank you. Yeah, that's fine. I would actually like to find out if there's another question that we can take. There's one here at the back.
Thank you very much for this really valuable insight for me. I'm coming from social science, so it makes me a bit nervous that you are not from social science, not one of you. But Chris, you said you are from social science. Maybe you can share some insights of if you see people transitioning from social science to data science and how it works, and maybe the others also can comment on this.
Can I quickly ask back which social science?
Well, basically communication studies, now political science and applied computer science combined.
Okay, fine. So generally it's possible. I'll relate an example actually with an economist. So I was recently talking to a behavioral economist who wanted to move into data science. And then he thought, well, I'm a behavioral economist, so maybe I'm good at looking at people's behavior, so maybe what I already bring is valuable to, say, marketing, yeah? And how people behave, and then you can look at marketing, sales, optimization, and this and that and the other. And yes, that's true, but that's not the only way of looking at it. We've had several comments today that indicated that at the moment, data science and machine learning is a very generic field. I sometimes like to call this the Da Vinci moment of data science or machine learning. And with Da Vinci, I do actually mean that Leonardo da Vinci and the way he was able to do a lot of things in his life because specialization wasn't really that important yet, right? And I have seen that people that come out of computational biology go on and do autonomous driving. Yeah, and what's the relationship between biology and cars? Well, there's the computational aspect, there's the computer vision, there's the interest in image processing, and there you go. Yeah, you can transition from computational biology to autonomous driving. What I've also seen that there's often not that much interest from social scientists, but if you do have that interest, I have a hard time actually really identifying an obstacle, other than that when you enter the labor market, you may find that your hiring manager or the human resources department or whatever needs a bit more persuading because you're not a physicist. But there are strategies of dealing with that, right? You can lean across the table and say, look, I know I'm not a physicist. I know I'm only a political scientist, but here you go. Look at A, B, and C. I can do this, right? So some awareness, yes, but I can't actually see a direct obstacle. Is there a further comment?
No.
Or another question over there? Yes, please.
Just short. Thanks again for the talk. So obviously you already made the transition and there was place for you in the data science world. And obviously there are a lot of people here also considering making transition more or less drastic. Do you think there is some sort of threat of saturation of the market? That a lot of people will try to make the transition, but the places, the workplaces around there will not suffice compared to the number of people that are actually trying to make a transition? That people will leave their education behind, make a switch, but there will just not be sufficient places around there? Or do you think the capacity of the market is only growing right now?
Daniela?
So it's a lot more difficult to start as a junior data scientist now than it was maybe 3 years ago, just because there are more people who are applying now. I also think at the same time the market is growing, so the offer is growing. I don't know whether there will be or when there will be a market saturation, because these like two moving variables basically. Yeah, sorry.
I think it comes down again to this level of specializations that we have. Is that currently transiting to be a data scientist in a business? I mean, 3 years ago, every company wanted to hire data scientists, and the reality was they wanted to have a business intelligence person that is able to make their reporting working. So the definition of what data science is getting more and more crisp with time. And I think that what we see is the need is increasing for people that can use data-driven business people that can have an impact on companies. Every company out there needs that, and it's growing. On the other hand, the specialization in technology requires us to be more trained and more rigorous. So I think Chris is right here. We're in a transition phase period, and I think that people that want to reconvert has to know that the level of entry is how are you go more towards the business and impact side of data science, or you will have to specialize yourself. Either way, you need to train yourself of what you want to do. So I don't think we're still very much short of people that can use data to have an impact on businesses, and this trend will keep increasing for the next few years.
Okay, thank you very much. We've run out of time, so I'd like to ask you to join me in a round of applause for the panelists here.
Thank you.